Hey everyone, in this lesson we will study the spacing technique in Matlab. Many times it is common to create vectors that contain evenly spaced numbers, like the one shown below. We have this vector, this row vector, with the name of y, and we have inside this vector the elements 5, 6, 7, and 8, which is basically from 5 to 8 with incrementing 1 each time. So what does this even space means? This means that if you compute the difference from one number and its previous one is the same as the next number and the actual one. So in this sense, we see that 6 minus 5 is the same as 7 minus 6 and the same as 8 minus 7, right? So we only keep adding 1 to get the next number. Now, what if instead of 5, 6, 7, 8, we have something bigger, like all the elements in the range from 5 to 100? Well, this is a very long vector, so entering individual numbers one by one is not practical in this case. For our good, Matlab provides a very simple and shorthand method for creating evenly spaced vectors, and this is the 2 points operator. We have two ways of defining it. The first one is we define the first element, 2 points, the last element. In this sense, we will have the row vector that contains all the elements from the first number until the last number, included both, with the difference and spacing of 1 to get the next number. So we have 5 plus 1, 6, plus 1, 7, plus 1, 8. Now, this difference can also be a number different from 1, and this is something that we will see in a few moments. First, let's do a quick practice of this 2 points operator. Let's create a row vector with the name of v with the values from 1 to 4. On each element is separated by 1 unit. So we just have a Matlab script in the Matlab editor, and we just say v to be the vector from 1 to 4. Now, instead of writing this, we will use the 2 points notation like that. So when we run this, and keep in mind that here these square brackets are not necessary, we just run and we have the vector and the row vector 1, 2, 3, and 4. Now, as we've said, what if we want to create a vector of spacing different from 1? Well, we can specify our own spacing with the second argument into these 2 points. So we have 3 arguments. The first one is the first element. The second argument is the spacing between the elements in the vector, and the third argument is the last element. So we start from 30, we add 2, so we get 32, we add 2, we get 34, and so on until 36, which is the last element in this definition. So here we have a very brief workout. We need to create a row vector with the name of x that starts at 1, ends at 5, and has elements 0.5 apart. So now the spacing is 0.5. So we just say x to be 1, which is the first element. Then we write the spacing, which is 0.5, and then we write the last element, which is 5. So when we press run, we see that we have this sequence of elements, okay? We can move this, and we see that we have a total of 9 elements. Since if we go adding 0.5 each time, we have a total of 9 elements from 1 to 5, as we see in this row vector. Now, if what you know is the number of elements you want in this vector, so the size of the vector, rather than the spacing between each element, then you can use the linspace function. This is a predefined function in Matlab that has 3 arguments. The first argument is indeed the first element, the second is the last element, and the third argument is the number of elements that we need in this vector. So, what is the size of this vector? So, take a look at this example. We say that the variable x is equal to the linspace from 0 to 1 with 5 elements. So we have 0, at the end we have 1, and we have a total of 5 elements. What is the spacing? Well, the spacing here, it was set to be 0.25 0.25, okay? We add 0.25 to this number, we get 0.5. We add 0.25 to this number, we get 0.75, and so on. So this was a spacing automatically set from on Matlab. Since we only specify how many elements we want, we do not care about the spacing. So depending on the problem we are working on, we will need to use the spacing 2 points operator or the linspace function in arrays. So here we have a little practice. We have to create a row vector with the name of D that starts at 2, ends at 18, and contains a total of 5 elements. So the number, or in this case, the name of the array is D. The first element, we will use now the linspace function. The first element is, as we see, 2. We write 2. The last element is, as we see, 18. So we write 18. And how many elements does this array have? Well, it contains a total of 5 elements. So at the end, the last argument, we just write 5. So D is equal to the linspace of these 3 arguments. This is the first element, this is the last element on the vector, this is how many elements this vector has. So we just press the enter key to run this, and we see that D is the vector 2, 6, 10, 14, and 18, just like that. What is the spacing? Well, as we see, the spacing is 4. Okay, to get a next number, we just add 4. Alright, until now we have been creating row vectors. Now, what if what we want is to create a column vector? Well, both the linspace function and the 2 points operator can create row vectors and column vectors as well. The only thing that we need to use is the transpose operator. This is a operator that is written as a single quote, and it basically transposes or array. Remember that transposing an array is changing its row by columns, and vice versa. So in here we have the sequence 1, 2, and 3, right, to the variable x. So when we write this, we have a row vector, but we can set x to be the transpose of x. So now x is the column vector 1, 2, and 3. What's good is that we can use the transpose operator within a single command. So instead of rewriting the value of x, in just one command we can have this column vector. So here we have the sequence that starts as 1, finishes at 5, and has a spacing 2. So this is a row vector, but when we add this single quote at the end, then we convert this row vector to a column vector. So as we have, see 1, 3, and 5. Very well. Finally, let's wind up this lesson solving a very brief activity about spacing and transposing elements within a vector. So here they say in a single command, create a column vector with the name of v that starts at 5, ends at 9, and has elements spaced with the value of 2. So since here they specify the spacing, we need to use the 2 points operator instead of the linspace function. So we just define v to be the array that has the first element 5. So here we just write 5, like so. The spacing is 2, and the last element is 9. Right, but we need to create a column vector instead of a row vector. So we need to just add here a single quote, and this we can transpose this row vector, so at the end we have a column vector. Let's verify. We just run this, so we have 5, 7, 9, which is basically the vector that starts at 5, ends at 9, and has spacing 2. We see that this variable is also updated in the workspace. So with this, we finish the lesson on arrays and spacing in Matlab.